dynamic programming. So there is also, let's see, 20, 24. Um, okay, cool. So you can hear me and see my screen, right?
Yes.
So far in the world of dynamic programming, we have seen a couple of different things. We first saw the what question was it? Where did we start? Uh, I think stairs. We started with stairs. We'll visit that again sometime. Then we went into the gold mine. Then we saw backtracking. Okay, so these are all standard problems in DP. Backtracking was the one where the mice was in a maze, and then we in fact actually combined this with the gold mine problem so that we can try uh, in the LeetCodeWala solution. So now, there is one thing about DP. So usually there are, like, let's say, interviews made in all the interviews, there are non-DP problems and DP problems. The people usually get scared when they see dynamic programming problem. But the truth is, dynamic programming problem, if you get, you're done. You will completely win the interview. And here is the reason. So non-DP problems are almost infinite. I mean, not infinite, but at least the topics itself is multiple. Let's say there are search, matrix, sort, and all those stuff. And each of this can have its own different type of combinations of problems. Dynamic programming, in fact, has exactly one type of problem and exactly one type of solution. Problem and one type of solution. So only tricky part is here is identifying if the given question is dynamic programming or not. So remember when I was doing the sorting of all the questions, which of all the questions ever asked, first one was of course dynamic programming. Second one was max heap. I don't know why people are obsessed with both of these, but these are two questions they ask. Oh, I think I just remember what we were doing last time. We were discussing the questions that Qualcomm had asked me. Um, okay, so
Oh,
let's
right. Yeah.
right. So let me remember questions. What questions? Oh yeah, I have the actual board itself here. So let me finish that. I don't even remember that. Qualcomm interviews, perfect. So we saw this one question, which was basically okay. So we saw one question, which was here's a matrix. The 1597, 977. Oh, just walked into a trap there. Let's say 77, 88, 95, 123, 144, etc. So they told that this will always be less than this. So it's basically a sequential problem. What is the best way to go through this? Do you remember what was the solution we arrived at?
Yes, check the last element of every row. If it is less than, then keep searching in that row. If greater, then move to the next row and then.
Okay, so that is an order of, so now so let's start with brute force. Okay, so let's start with brute force. So we had the brute force solution. And what was the brute force solution?
Uh, Convert it into a list and apply like a binary search.
That was actually the easiest solution. No, that is not brute force.
Oh, brute force is.
So the question is, given 95, find 95. Okay.
Mhm. You go to every row and check every element.
So the brute force is basically two for loops. So if there are R rows and C columns, the two for loops is it is an order of R comma C. And what was the next solution you said?
Like convert the matrix into a 1D array and apply binary search.
That itself is actually a good solution. Order of log of, do you know what that is? Order of log of
And the total, I mean, n, where n is the number of elements in the matrix.
perfect row plus columns. And there was one more order of R plus C itself, which we discussed.
Mm.
And that is the one which you initially said. Just look at only the first elements.
Yeah.
Where the thing is, in fact, I think there might be one more better solution than this, which is so R plus C is look at the first elements and see if 95 is in the row. So for example, is 95 greater than 1? No, is 95 greater than 88? Yes. So then you go search in the row linearly. So I think there's one more innovation possible, which is first you take this this head alone, which is the very first elements of the row, do a binary on it. So log of R plus log of C. Basically, once you identify the row, do a binary search to identify the row, and then you do another binary search within the row itself to identify column. I don't know if log of R plus C is greater or lesser than log of R plus C, but that is another solution. Okay. Okay. So the second question was, I think, this one, the cluster count. Cluster count was, I think we solved it, no?
I don't remember the question. Cluster
I'll tell
count.
you. Yeah, okay. So this, what happened? What is responding? Nope. कहाँ से आ जाती है? So the cluster count question was, can you please wake up? Okay, there you go. So here are a bunch of servers. So let's say we all start with zeros in the grid. 0, 0, 0, 0, 0, 0, 0. But in this grid, there actually exists a bunch of clusters. And the clusters are like this. So here, okay, so let's say the clusters goes that here there is one cluster which is server 1, server 2, server 3, server 4. And in here, there is another separate cluster 5 here, and maybe let's add one more row to it. We'll add row. There's another clusters all 0, 0, 0, 5 and 6 here. So the question was, given this kind of a clusters, find total number of clusters. And the definition of cluster is, if you pick one element in a cluster, you can look top, left, right, and center. If you have at least one neighbor in both directions, that is a cluster. So how will you do it?
We can use DFS approach in this. Basically, if you iterate through the grid, if you come across a number which is not a zero, then recursively call on its children in 4 directions, and keep marking them kind of visited of some sort, so that you don't you don't recount them. And yeah, and then um, move to the next element. If it is already visited, then skip it. If it is a non-zero and already visited, skip it and keep moving like that.
Okay, perfect. Yeah, that's exactly the solution I provided them. So this is basically a DFS problem looking for visited, and I think we solved this also last time. Yeah, so is valid is visited. Okay. This was the problem which we were looking at. So this was
Yeah.
question was, yeah, so here, please work. Okay, so you have memory here, right? And we have huge amounts of file here. So there are some files sitting in the disk, and the files are here. These files have each of them as 500 terabytes each, right? 500 TB. Your memory is only, let's say, 18 GB, right? And the files are of this format where you have file 1, file 2, file 3. Okay, so this is entries like this. The entry is key value pair basically. So item 1 has a value 3, item 2 has a value 4, item 3 has a value 6. In this one, item 1 has a value 4, second one has a value 9, 3 has a value, so let's say in this case 3 doesn't exist. There is 4, and 4 has a value 11. File 3, item 1 has a value 2, item 2 doesn't exist, let's call it item 3 has a value 5, item 9 has a value 13, etc. So this keeps going. These are different files. Your question is create an output file which has values like this, and the values are key is 1. The value must be the sum of all the values 1, 3, 4, and 2. So that is 3 plus 4, 7 plus 2, 9. 2 is 4 plus 9, 13 plus 5, 18. And 3, you should only look at where text is 3, 6. There's no 3 here. So you go 6 plus 5, 11, so etc. etc. So let's say initially, if I tell you there is no memory restriction, that is all these files are originally, let's say, MBs, right? All of them are megabytes. How will you do it?
Can you repeat about the size part?
So no, so I'm saying, so okay, I told you that each of these files are residing in the disk, and initially it was 500 terabytes, but now I'm changing the question saying, let's say there is only, all of these files are only 1 megabyte, right? And your goal is you have memory RAM, which is 18 GB, for example, and then
Okay.
the question remains the same. How will you do that?
If everything, all the files can fit in the memory, then I will basically combine all the files into one and iterate over them one by one. And create a new file. If the key already exists, like for example, 1, then I will sum up the values. If it is a new key, I will just add into the new output file.
So you're saying first thing you will do is you'll make a file 4, which has all these values, like 1, 3,
Okay, okay.
1, 4, 2.
Uh, okay. Yeah, probably I'll explain it better. So first, if all of them can fit in one, like all of them can fit in one RAM, then yeah, one option could be I can combine all the file information and create one big file. But I don't know what is the benefit of doing it. So maybe let me just iterate it one by one. So for example, I will create an output file because the max size of the output file, I'm sure that it will fit in the RAM, because if all of the individual files can fit in the RAM, even if they don't have overlapping values, the output file can also will be sufficient enough. So I'll create one output file, iterate over file 1, file 2, file 3 one by one. So file 1, I'll see one is the key value is 3. So I'll put that in the output file. And when I iterate over the file over file 2, I'll see if 1 already exists in the output file. If yes, I will sum up 4 plus 3. Otherwise, I'll just append the new entry, something like that. Also, now I have one question. Like, is the I think I asked this earlier as well. Like, the contents of the file, like 1, 2, 3, the keys, are they sorted, or can they be in any order?
So let's ask sorted.
Okay, we can do something like, so that is one approach. Another one that comes to my mind is we can have like 3 pointers at the beginning of every file. So let's say it's one, we have one pointer at the beginning of every file. And if in this case, all of them are, the keys are same. So we will increment that, put it in the output file and increment the pointers.
Yeah,
And
that's the model. Okay.
yeah.
Okay. So my question there is, your initial initial answer was assuming this was unsorted, is it?
I don't know, it will still work if it is sorted. But yeah, not
No, I mean, my
very,
question was, did
it's
you
not
assume it
making
was
use
unsorted?
of, sorry?
So when you said one big file, did you assume it was unsorted?
Yeah, but I didn't, but that brute force logic would still work if it is sorted. But yes, I assume that it is unsorted.
Cool, no problem. I'm just trying to understand this as brute force. Now, second one you said is 3-pointer, which essentially is merge sort. But if I tell you it's unsorted, what will be the best way to do if not brute force?
Then I can probably sort individual files and then apply merge sort.
So you're saying, okay, you sort this, that will take order of n log n, plus it'll take an order of n to merge them together. Like each of the files is sorted, and then you minimum order of n to merge them together. Can you do better than that?
I'm not able to think of anything better. But let me try.
Yeah, I mean, no pressure. Take your time, take 5 minutes. Don't have to speak for 5 minutes.
Okay. There is this external merge sort algorithm, but I think it's same as merge sort in this case. External merge sort would only apply if the files are 500 TB, but you remove that constraint as well. So that is out of the picture. No, I don't think so. I have anything better in mind
That's
right
no
now.
issue, no issue. So this is I'll give you a hint. This you can do without sorting itself. You can do the whole thing in order of n, where n is the total number of entries. So for example, your first file will have 7 entries, second file 18, the fourth file will have 10. So the total is 10 plus 8 plus 17, 25, right? 25. So you can do it in order of 25. So assume it's like, okay, this is first key is 99, and if that's the first key's value is 3. Then there is 1 whose value is 4. Then there is 127 whose value is 6. Same thing here, it might have 99 as 3 here. Maybe the 127 is the first one here. So it's basically unsorted. Okay. So this one maybe will have 1 in the beginning, then you have 99 here somewhere in the middle, etc., etc. So if this is unsorted, how will you do this in order of n? Or when I'm saying order of n, sum of 7 plus 8 plus 10.
So I will iterate over file 2. I'll keep file 1 intact and iterate over file 2. 127. I'll look this key up in file 1. If it exists, then I'll sum up the values. If it does not, I'll add it and then move on to
So
the
when
next.
you say look up, these are files, literally they have entries, okay, one after the other.
Like text
This is
files.
text files, yes.
Mm.
Sitting as text files in the disk.
Yeah, then it's tricky. Like I have to split them and use data structures like dictionary to parse those values. And since I have space in RAM, I can up, apply sorting algorithms or searching algorithms. And
No,
once I
but
find the answer, I will output them to the file.
you actually said the answer. All you need is a hash table. I know. So let's say you start with the first one. You create your own independent hash table, right? These 3 files, you're reading file 1. Okay. File 1, file 2, file 3. So you create your own hash table here. So now you are in entry 1, file 1. So which is, okay, let's say you create 99, you add a value 3. Then you saw 1, you add the value 4, key, value. Then you saw 127 in this first file, 6, and the first file is over. Then in this one, you see 127, you immediately go to this. So I'm saying you're here, right? So you finish this, you finish this, you finish this, you're here, 127. So all you have to do is 127 plus 6. And then you again see 99 of 3. So you just go 99 plus 3 plus 3, right? So this way, you just have to maintain one hash table. And by the end of reading all these 3 files, you'll have one hash table with the sum of all these values. And all you have to do is write that as an output file. Okay. Now, those all that were sample starting questions, right? This was just beginning questions, just to check if you understand the basic data structures. Now we will go back into the actual crazy question. The crazy question is, we're going back again and saying that, hey, now each of these files is 500 GB each, right? I can give you 3 API calls, right? Let's say there are only 3 files, 3 API calls, um, file 1, file 1, file 2, file 3. So you have something sitting with you, which will give you first line, or let's say some kind of function, which is dot get next line of a file name. Okay. So you can call that infinite number of times, get next line. Okay. So now given this constraint, how will you, and okay, I'll also make it easier. So let's say the all files are sorted. Okay, so this is very close, similar to a merge sort idea itself. So if that is the case, what is the optimized way of writing an output file? So we are going back to the original one here where this is sorted. One has a value 3 and one in the first file. One has a value 4 in the second file. One has a value 2 in the third file. So your job is to write an output file which has one whose value is 3 plus 4 plus 2, that is 9. Two's value is 2 plus 4, 4 plus 9 plus 5, 18. Okay, etc., etc.
So I think same approaches like before, but it's just that we'll use the API like when I was saying that I'll move on to the next line and get the next entry. Instead of that, I'll just use the API.
Fair. Okay. So here, when we initially you said this was the three sorts of question, right? So yes, memory, when I was saying this was one big file, we saw it all fits in the memory, so that's good. So no memory, and there are two options. First one is I said it's sorted. Okay. So and which you said, okay, merge sort will work. We can just do one at a time, keep moving the pointers, you know?
Mhm.
Okay, so now I'm asking, what if these files were unsorted? So again, when I say unsorted, the point is it looks like this, which is these have entries 99, 1 to and 127 key values, key, and the value is 347. The 127 here might be the first value in the second file. The one here might be the first value in the third file. If that is the case, how can you write an output file like this? What do you think is a good way of solving this?
So in this case, all the files will not fit in the memory, or what about the
Correct.
files?
So this is all. We are back to the no memory
Oh,
area,
this
which is
okay. Mhm.
all of this is 500 terabytes of file, but your memory is only 18 GB. But you still have access to that one function, which is get next line. You can get the next line.
And files are unsorted.
Unsorted. The entries of the files are unsorted. Yes.
Then I will just bring in a chunk of file one, how much ever like will fit in the memory, and process that and generate my output file and move on to the next block, which is not processed. And basically throw that out of the memory, clear the memory, and then bring on the next chunk.
Okay, so what you're saying is you have a RAM, and you have three of these files. They are infinite, huge files. File 1, file 2, etc. File 3. So you're saying you will get the first, let's say, 10 entries, right? From here, you'll take, let's say this file has entries 99 is the key, 127 is the key, 13 is the key. So you're saying you will bring that guy into the memory. You'll just have 99, whose value, let's say, is 4, 19 has a value 4, 127 has a value 3, 13 has a value 5. Okay, so 13 has a value 5. So now what will you do with this? Oh, so you'll do that directly, write it into another file in the disk, is it? Output, is that
Mm,
what you said?
yeah, because I do need to store the output somewhere. Yeah. So
So
I need
what
to
is
have
the out?
space for one more file in the RAM.
Okay, so what your point is you're getting a chunk of your first file, okay. And that is, let's say the max chunk size is 18 GB, which will fit inside your RAM, okay.
Mm-hmm. And then
So
process
what
it,
will be the file?
write it.
What
ri- Yeah, process it. I mean, I'll use the API next line and keep going through each line and check. Basically, create a hash table of the first chunk which is
in
in the
memory?
RAM. Yeah. Yeah.
Okay, so you're saying within the RAM itself, you will, is that too lighter color?
No, it's fine.
Okay, so in this, you're saying you'll create a hash, oh, Jesus. You'll create a hash table in memory
Mm-hmm.
where your first entry will be 99, whose value is 4. Second entry will be 127, whose value is 3. Then the next entry will be 13, whose value is 5. Okay, so you keep doing that for the entire file, first file, and there won't be any repeats within the file. That I can assure you.
Mm-hmm.
Okay, so you keep doing that, and now you're saying you will bring another chunk of memory from here, file 2, And every line you see, you go look up and keep populating the hash table, right?
Something like that, yeah. Mm.
Okay, so let's say there is 119, 15, there's all the keys here. Okay. 6, etc. So you're saying when you see 127, you will go back to the hash table and change the value. Like let's say this, the 127 in the second file had the key 127 and the value was 3. So you will go back and add 3 plus 3, etc. Right?
Mhm.
But my point is, this guy has 500 terabytes of data. So that itself, how will you fit this whole in the file one? How will you fit this whole hash table itself in memory
Mm.
for the first file
Yeah,
itself,
good
left
point.
alone the rest of them?
Understood. I don't know, like this question really, like, I don't think I was able to do it last time as well. It's
No, that's
confusing.
okay.
Like,
That's
I
fine. I'll
don't
do.
know what more I can do in this. I thought of the only others that like external merge sort algorithm comes into my mind, but files are not even sorted in this case. So,
Correct. Okay. So what if I tell you? I'll give you a hint, and the hint is, let's say you can take 10 lines together or a chunk of lines from each of the files. So 10 lines from file 1, 10 lines from file 2, and 10 lines from file 3. But remember, they're not sorted. So when if you do the first 10 lines, you might be getting from the file 1, you might be getting things like, okay, so you file 1, you got key and value, which is 127, 99, 17. You got some random values, 13, 4, 5. And file 2 might not even have the same set of values. It might be completely different. But the 10 values, you can get 10 values. This will be 1, 2, 3, 4, 5, 6. Let's say it's not even sorted or sorted, whatever. So, but my point is these two are different values. But at the end of the day, you can have 10 plus 10 plus 10 equal to 30 entries together in your RAM.
okay. So, okay, if I can get 10 lines of each file at once in the RAM, I will take those 10 lines in the RAM if they exist and create a hash table out of it. If there are any keys which are repeating, I will sum it up. I'll have that algorithm in place. And once I'm done processing that, I'll move on to the next 10 lines of every
But
file.
we'll run into the same problem, right? This hash table will become so big sooner. This is the same idea that you told earlier. Key, we are instead of getting finish file 1 and then second time you go to file 2, file 1 ke liye you'll create a hash tables
Mm-hmm.
and then you start adding file 2. That's when I said, okay, but file 1 itself won't fit in your memory. What will you do?
Right. Yes, you're right. The output file will not have enough space because it will keep increasing and then it won't fit in the RAM anymore. Is that what you're saying?
Yeah, if you output file name, if you're creating hash table like a data structure in memory, then you will not be able to store it in memory completely because this
Mm-hmm.
will keep going. Even if you do 10 at a time, that is, even if you do horizontally or vertically, the same problem arises. Horizontally is
Okay.
you finish one file, do the second file, but sooner or later you run out of memory because let's say you will write this to the disk. Okay, when you run out of memory, so you wrote 99, 127 and 13 into the disk. Okay, so 4, let's say 7, 5, you wrote these values, you finished file 1 and file 2, but file 3 you might encounter 127 later, not within the
Right.
first lines that you came up with in memory. And that guy is sitting again, your output is sitting already in RAM, so you cannot bring it back into memory.
Mm-hmm.
You can, but this will be a huge mess because you'll have multiple hash tables.
So if my hash table will keep increasing, when I move on to the next, before moving on to the next 10 lines, whatever current output I have, I will store it in an output file. But no, I don't actually. Then I have to bring it back. I don't know. I'm not sure. I give up.
No, I mean, it's okay. We're just restarting after 20 days, 10 days gap, so that's okay. Let me see if I have pictures of what I did that day. It's cluster problem, this here. Okay, merge sort. Okay. So basically we wrote code only for merge sort, and then he said he posed this problem. So what at least what I suggested was a solution was, so let's say you have 30 entries, and of the 30 entries, what I'll do is I will keep a min heap of these 30 entries. Okay, so let's start with min heap of 30 entries like this. I know we haven't talked about min heaps yet. But I'm saying every time I add a new entry, I will rebalance the min heap. Right. So at any given point of time, I will always have this one guy sitting there. One is the lowest value in all the files, and his value sitting there. Okay. So now let's say I add 127. The 127 is going to go sit somewhere else with its value. But I will sum it up only when the next time one hits. So my min heap will always have the minimum value. Okay. So this I think will work only if the files are sorted, right? Because if it's unsorted, it might not work also. What was it? Yeah. Let me see. Min heap. There was some solution like that which I forgot now. I said keep a min heap, and once you have seen this all the three files thing, you always have a continuous set of min heap which is sitting there and keeping track of the minimum value. So even if it's 127, 93, whatever, doesn't matter, your minimum value is still 1. So you keep going until you hit the minimum value, and then the moment you hit it from all the three files, you write it to disk 1, 2, right? So your min heap will keep building. There's a worst case scenario. You might end up with a min heap without seeing any of the other values, but it is a continuous input and output process. The output and input process is continuous, because of which there's a possibility that this might work out. That is 1, 2, you saw it in all files. Okay, you wrote it to disk. So your min heap is reduced by one size. Then you see 2, 3, and you wait for 2, 3 to show up in all the other files. Then you reduce it and then you write it to disk. So this is what I proposed, and he said he was okay with it, so I didn't complain about it then. But now I'm thinking, okay, maybe it has to be sorted, or either way might not work on second thoughts.
But you said
But
it
yeah,
was
the whole
sorted.
idea
The
is,
question was in question, it was sorted, so it would work, right?
no, if it was sorted, why don't we do merge sort itself?
Because the memory constraint.
No, merge sort, we can keep things like this, right? If it was sorted, we can have one pointer here, another pointer here, and these things are not sorted internally. So okay, you cannot do merge sort. Okay, let's say your new goal is you have files which are sorted. So this is key value pair. So now I don't remember why the solution was okay. This is stupid. 1, 5, 7 are the key. 2, 4, 6, 3, 7, 9. This has its own values. So let's say whatever the value is. So if you put 3 pointers of a merge sort, so why won't that work? I'm not taking the whole files. Every time I call a new pointer, so I'm saying, okay,
Because you
first
told
time
if the files are not sorted, then it will not work. For it to work, the file should be sorted. And then you said, no, the files are in unsorted
okay, so
fashion.
if the
That's why.
files are unsorted, will the min heap work?
I don't know. I didn't quite
Let me
understand
think.
it.
Let's think this through. So because At that time, I said min heap, maintain a min heap in memory, and he was happy with it because every time when you have to balance it, all you need is a log of n to balance the min heap. Every time a new entry comes. So even though he told me, oh my God, this is supposed to be a hard problem. You solved it in 30 minutes, blah, blah, blah. Now, when I look at it, I am thinking maybe that was a wrong solution. Let me see. Let's assume it's unsorted. If it's sorted, it's an easy problem. Unsorted. So let's say every file you get 10, from every file you get 10 lines each into the memory. Okay. So you create a min heap out of it. Okay, so let's say your initial min heap, let's say where are the file, the entries we got was 127, 19, 17. So then every time, so we create a new entry, we balance it. 17.5 is at the top of min heap. Then you'll have 99, 4 here. And apparently in Python, you can sort it by tuples. I didn't know, he told me that you don't have to sort it by key alone. Okay, so now you get an entry, let's say min heap is there and you get an entry 1, 2. So now you add 1, 2 and rebalance it. So that will become 1, 2, 17.5, 99, 127, whatever. So we'll see that min heap in soon. 3. So I'm saying next, then we keep adding, let's say file 1 gave you 1, 2, file 2, file 3, this way, and file 2 now gives you again 99, its value is 5, so you bring 99, so you'll ignore it? Good question. You'll ignore it or will you go find 99? If you go find 99, maybe you'll go find 99 and add it up. Okay, anyway, I don't know what is wrong here. Maybe I'm not saying the question correctly, but that guy was happy with that solution. And I said, okay, maybe that's right. I forgot. But anyway, so this I think will serve as a good welcome back for us after a big breaks. Just tickle our brains. Yeah, I see. I already said, okay, let's see. File 1, 1, 2, 3. Okay, 1, 2, 6, file 1, 2, 4. Sorted. Okay, so it looks like his files were sorted. Yeah. 1, 2, 3. Yeah, his files were sorted. So if it was sorted, you don't want to do merge sort. Okay. So even if it is sorted, merge sort won't help because after a point, you cannot keep all of it in memory, all of the chunks in memory. So you have to start writing it out, and merge sort will still be order of n, where n is sum of all that. But instead, if you are merging, okay, if you merge, so if it was sorted and then you are merging with a min heap, this will be easier because once you have seen entry 1, like in our case, for example, once you have seen, so let's say these files are sorted. So again, we write 3 files. Okay, so the only difference is in this case, let's say this is 1, 5, the key values, the 2, 7, 1, 9, and some values. This is 3, 4, 5, 6, 7, 8. So you cannot keep a merge sort because this is so huge that you cannot keep adding them in memory. That will end up. But the idea was you have to throw something out, and what will you throw? The throwing things out is basically decided by your min heap. So your 1, 3, if you see, okay, you see 1, 3, okay, you added it to min heap. Next, there were 3 pointers. You added 2, 5, and 1, 7. Okay, now you encounter 1, 7. So you add 1 plus 3 plus the minimum value is always the one which is added. So 7 plus 3, so it will be 1, 10. Then you see 5, 4. So 5, 4. So, and then the next time you see 5, you keep the minimum value always at the min heap, and you write it only when you have seen all the 3 min values from all the 3 files. Okay, so if after this there is no 5 here, you know the file 5 is not going to come from that file. Okay, so that is why, and you keep writing this to disk. Okay, that is why it was efficient than merge sort. I see. Okay, fair. Anyway, I think these questions are stupid anyway. So let's break there. This is our welcome back. We'll next class. So my plan is so we did what my machine is doing today. So far, gone. Yeah, completely gone. I don't know if it's the internet or the local machine. Somebody has to respond. Okay, so the idea is so far we have seen things like what else? Dynamic programming. I was going by the max bang for the buck. Even in dynamic programming, we saw there's one more thing, standard problem we'll see. In dynamic programming, we saw stairs, we saw the mine, gold mine, then we saw rat in a maze, and then there is backtracking, which we again the rat map. Okay, that is rat in the maze, backtracking, which we used in the mine. The only thing left is coin change. We'll do that. Then what we'll go then. Actually, I don't want to tell you where we're going because that way I want you to we will come prepared mentally for that topic. So I will
Okay.
not tell you what the topic is, but my point is, after this, there are like we have covered between DP and the rest of the things. Like I even forgot what we saw, like sliding window and all that. We have covered like 60% of all interview questions. Rest of them are rarely seen, but still will do it. And let me see if I can tell you a random list of names at least. So this will be, things like, in not, this won't be the order we'll follow. I'll randomly pick an order. So we'll go look things like here. I think we already saw linked list, stack, and what else did we see? Binary tree. So all these things together, 60% of the problem. Once we add the coin change also to dynamic window, we even saw like a sliding window somewhere. Now there is the things that is left are like searching, which we encountered binary search in between, but there are more ways. Searching, then there is an entire class on HashMap itself. Sorting, then there is graph where we have a topological sort and all that stuff. So these are the little, what I call the not so important ones, but they keep showing up once in a while. So it's still important, at least in the round one. So this keeps showing. Rounds, like higher rounds is almost always DP, min heap. Oh, sure. We have to explicitly look at min heap here. Yeah, okay. So min heap is something which is a major chunk. Between DP and min heap, you will get cover like 80% of things, and the rest is all little things. But since we were going at that time, you had interviews going on. I thought it's more bang for the buck if we start probability of you encountering a DP or a min heap was higher. So that's why we started. Okay. All right. 1 second. Let me stop the recording. Stop recording.